Hello all. In this video session we will be discussing about recursion. Now a function which calls itself is known as a recursive function, and this technique is known as recursion. When you consider a recursive function, it calls itself and also there is a base case or terminating case upon which this recursive call terminates. Okay, so remember about these 2 points. We have said that in a recursive function there is a base case, and consider that a function is calling itself, and if there is no base case, it will keep on calling itself again and again. Whenever a function call takes place, its context will be stored in the stack. Okay, stack that we discussed when we discussed about the memory layout of C program. So in that place, with respect to every function call, these context or activation record or stack frame associated with a function will be populated on the stack, and as we keep on calling itself, the stack memory keep on increasing until it reaches a point where there is no memory left for allocation of more function calls, and which will result in stack overflow. So just remember about these terms. Now we will see recursion with the help of an example. Now this is a simple recursive program to find sum of first and natural numbers. So here we have the function sum. It is accepting a parameter n, and it has a base case. So when n becomes 1 or n is equal to 1, it will return 1. So that will be our base case, and for every other condition it will return n plus sum of n minus 1. So here inside the sum function it is again calling the same sum function. So this is called recursive call. Okay, so this is our sum function. Now we have the main function. Inside the main function we are inputting a number, and then we are calling this sum function. Okay, so this is the basic logic of our program. So as you all know that if we want to find sum of first and natural numbers, we can add the last number with sum of all the previous numbers, which is equal to again n minus 1 plus sum of the previous terms, that is sum of n minus 2 terms. So this process will continue until it reaches to 1. Okay, so associated with every function call, the details like local variables etc. are stored in a place called stack. Okay, so now when this main execution of the main function starts, what happens is that memory will be allocated for this main inside the stack, and information such as the information about the variable num etc. will be allocated inside this stack. Okay, so here this is actually main function and no one is calling this main function, so it won't be having any return addresses. It will only having the number. Okay, once the execution starts, memory will be allocated for num, and then we have read value for num, which is, I consider that is 4, so we'll be having 4, and it will be allocated inside this stack frame or activation record corresponding to the main function. Then this statement is executed and sum of num is called. So this is the calling function and this is the called function. So main is the calling function and this sum is the called function. So here we are calling this sum function, and okay, I will say why I have written it here. So this is not an actual representation inside stack. For sake of simplicity, I have just written that here. Okay, so from here we are calling the sum of 4 function. So inside that we will be having the argument or parameter n, which is equal to 4. Then we will also have the return address, which will be going to the code here. Okay, our code is stored in our text segment. So this sum for this stack frame for sum of 4 function. Okay, sum of 4 function will have the return address which is going to here. Okay, so for simplicity to locate that particular position in main, I have just written sum of 4 here. So this return address will be taking to sum of 4 in main function. Okay, so now sum of 4 will be calling it again here 4 equal to 1 false. So again this statement will be executed, that is 4 plus sum of 3, and we will be calling the sum of 3 function, and sum of 3 will be returning value here. So that's why, sum of 3 will be value returned here with the context n equal to 4. Okay, so that's why I have written this statement here. Okay, then after that sum of 3 will be called, again 3 equal to 1 false. 3 plus sum of 2 will be returned, so again sum of 2 is called, so again sum of 2 function call will come to sum of 2. Here 2 equal to 1 is false, so again 2 plus sum of 1 will be returned, so sum of 1 will be called, so again sum of 1 is again recursively called, we are calling the sum function, so sum of 1, here 1 equal to 1 true, so the sum of 1 will be returning the value 1 to the sum in the previous called sum function. So this 1 will be returned to sum 1, so this sum 1 will be having return address, that is here, so this 1 will be returned to here, so it will become 2 plus 1, then this value will be returned to sum of 2 in the previous called function, and this address will be contained inside this stack frame, so this 3 will be returned to here, and it will become 3 plus 3, again this sum will be returned to sum of 3, the return address is here, so 6 will be returned here, and then we have sum of 4 which is 10, which will be returned to the initial call from the main, so 10 will come here. Okay, so this 10 will be printed here, and after that return 0 value will be returned, and this function terminates, and then this context of main will also be popped from our stack. Okay, so this is how a recursive function works, and we have just seen an example to find sum of first n natural numbers. Now we will see how we can find out nth term in a Fibonacci series using recursion. Okay, so we have a recursive function fib, and it is accepting a parameter n, and we have two base conditions, that is if n equal to 1, that is if it is the first term, return 0. If n equal to 2, that is if it is a second term, then return 1. Then we have the recursive calls, that is return fib n minus 1 plus fib n minus 2, that is we can get the nth Fibonacci term by adding the previous two term in the Fibonacci series, that's why it is given fib of n minus 1 plus fib of n minus 2. Okay, so it is making two recursive calls. Okay, so this is our base case, and this is our recursive calls. Okay, calling itself. Now inside the main we are just accepting a number, and then we are printing that particular term in Fibonacci series. Okay, so now consider that our execution starts. So this part, all the context of main function will be stored, so the detail of num will be stored, and we are assuming that we are giving input 5, so 5 will be stored here, and it will be stored in this portion of the stack for the main function. Then after that this function is called, when control comes here, this function is called, so we will be calling fib of 5. Okay, so this is not the actual representation, for the sake of simplicity I am just representing it as fib of 5, since it is the place where the control should come from the called function to the calling function when this function terminates. Okay, then fib of 5 is called, so inside fib of 5 n equal to 5, and if we check n equal to 1 and n equal to 2, both are false, so again return fib of n minus 1, that is fib of 4 plus fib of 3 should be returned, so again fib of 4 is called, so 4 equal to 1 or 4 equal to both are false, so again fib of 3 plus fib of 2, right, n is equal to 4, so fib of 3 plus fib of 2 is to be returned, so again we have to call fib of 3. Now fib of 3, again functions come here, and again for that particular function a context is to be created, here n equal to 3, and here 3 equal to 1 false, 3 equal to 2 false, so fib of 2 plus 1 will be to be returned. Okay, so fib of 2 plus fib of 1, again fib of 2, if function comes here, then fib of 2 will be having the value 1, so 1 will be returned to fib of 2. Okay, then again if fib of 1 is called, then it will be n equal to 1, so it will be returning the value 0, so 0 will come here. Okay, then again here 1 plus 0, that is our function fib of 3, it will be returning the value to here fib3, so 1 will be returned here. Then 1 plus fib2, so fib2 is again call here comes, and n equal to 2, so it will return 1, so here will be 1, so 1 plus 1 will be returned to fib of 3, so 2 plus fib of 3, again fib of function is called, so fib of 3 here 3 equal to 1 is false, 3 equal to 2 is false, so again fib of 2 plus fib of 1 is called, or it is to be returned from here, and fib of 2 will return 1, so it will become 1, and fib of 1 will return 0, so it will become 0, and it will return this value to fib of 3, so 2 plus 1, and then it will return this value to the initial called function, so it will be having the address of fib 5 or fib of 5 in main, so this will be returned to here, and we will be having the value 3. Okay, sum of Fibonacci, nth term in Fibonacci series, first term is 0, second term 1, third term 1, fourth term 2, fifth term 3. Okay, so this will be printed, and once this execution is completed, this stack will be popped. Okay, or the activation record containing the information about main will be popped. Okay, so this is how we perform recursive operation to find nth term in a Fibonacci series. Now, one of the things that you have to remember about recursion is that anything that we can do with the loops can be done using recursion. So recursion is used to do some execution of step of codes repeatedly, and recursive is more expensive than loop, but recursive functions are more readable and more easier to write at certain scenarios, like when we are traversing through a tree or traversing through a graph, etc. Okay, so just keep that in mind. Okay, then try exercising these programs so that you can get a better idea about recursion. Also work out some practical questions. Okay, thanks.